The concept of a cosmic barbarian refers to the process where massive galaxies devour smaller satellite galaxies. Evidence of this violent phenomenon can be seen in the structures of the Andromeda Galaxy, where regions like M32 and M110 still exhibit the aftermath of such interactions. Surprisingly, our own Milky Way has not remained untouched by this cosmic aggression, as it too has absorbed smaller galaxies in its history, and it is currently in the process of consuming the Sagittarius dwarf galaxy. Cosmic barbarism plays a significant role in the evolution of galaxies and in shaping the large-scale structure of the universe. These galactic collisions and interactions contribute to the universe's ever-changing nature, just as peaceful relationships between galaxies or near encounters between them do. The universe is in constant motion, and galaxies continually reshape each other through these gravitational dances. This dynamic process creates a fascinating interplay where galaxies evolve and influence one another. One of the most remarkable galactic collisions currently taking place is between the Milky Way and Andromeda. Andromeda is hurtling toward us at a speed of 110 kilometers per second, and we are also moving toward it. In about 4 to 5 billion years, the inevitable merger of these two galaxies will reach its peak, resulting in the formation of a new galaxy, often referred to as Milkomeda. This collision marks the end of two separate cosmic entities and the birth of a new, larger galactic structure. While this event is millions of years away, it will be a slow and steady process. As the two galaxies draw closer, their gravitational fields will begin to interact, causing significant changes to their structures. Initially, the outer stars of both galaxies will have their orbits disturbed by the gravitational forces of their counterparts. This will lead to a chaotic rearrangement of stars and star clusters, with some stars potentially being ejected from their galaxies, drifting through the vastness of intergalactic space. As the Milky Way and Andromeda galaxies continue their gravitational dance, it will not only affect the stars but also the interstellar medium, the gas and dust between stars. The collision of gas clouds from both galaxies will trigger intense bursts of star formation, as the pressure waves compress the gas, leading to the birth of millions of new stars. This phenomenon is not only a spectacular display of cosmic proportions but also an essential process in the evolution of galaxies. During this turbulent merger, the supermassive black holes at the centers of both galaxies will play a crucial role. These black holes, which have grown by accumulating surrounding gas and stars, are millions to billions of times more massive than our Sun. As the galaxies merge, these black holes will move toward each other, eventually colliding and merging into a single, even more massive black hole. The collision of these supermassive black holes will release enormous amounts of energy in the form of gravitational waves, ripples in the fabric of spacetime itself. Predicted by Albert Einstein's theory of general relativity, these waves were recently detected by Earth-based observatories. The merger of the Milky Way and Andromeda's black holes will be one of the most powerful events in the universe, potentially detectable by future astronomers with advanced instruments. The effects of such a merger will extend far beyond the immediate aftermath. Galactic mergers like this are key moments in the evolution of the universe, influencing the distribution of matter and the formation of new galaxies. The collision between the Milky Way and Andromeda is a prime example of how galaxies interact on a grand scale, contributing to the intricate tapestry of the universe we observe today. While the merger of our galaxy with Andromeda may seem like a slow-motion collision from our perspective, it serves as a reminder of the dynamic and ever-changing nature of the universe. Since the beginning of time, galaxies have evolved through mergers and interactions, with smaller galaxies being swallowed by larger ones, and the largest galaxies forming through the fusion of similar-sized systems. These interactions not only reshape the galaxies involved but also have profound effects on the conditions around them, triggering bursts of star formation and altering the distribution of dark matter. Dark matter, a mysterious substance that makes up around 85% of the matter in the universe, plays a crucial role in the dynamics of galaxy mergers. Rephrase it. ChatGPT said. ChatGPT. A disturbing signal has been detected by the James Webb Space Telescope, and it originated from our neighboring galaxy, Andromeda. This magnificent galaxy, home to trillions of stars, is one of the most beautiful in the universe, but it also holds a darker side. Andromeda is known to consume entire smaller galaxies and is currently speeding toward our Milky Way at a rate of over 100 kilometers per second. Is this strange signal a forewarning of the eventual collision between Andromeda and the Milky Way? Or is it the result of an unexplained cosmic phenomenon? When Webb turned its advanced instruments toward Andromeda, it revealed something extraordinary. This galaxy has shown us that it's not quite what we once thought. Back in the 1920s, astronomers like Harlow Shapley, Heber Curtis, and Edwin Hubble made groundbreaking discoveries using the best technology of their time. With advances in electrical engineering, telescopic observations drastically improved, allowing astronomers to peer beyond the Milky Way for the first time. At that time, Heber Curtis believed that the Milky Way was the entirety of the universe, while Shapley argued that there were indeed other galaxies, and that the universe was far bigger than anyone had imagined. Curtis and Hubble had observed strange nebulae beyond the Milky Way, one of which they called the Andromeda Cloud, because it appeared to be hidden behind the constellation of Andromeda. Initially, the academic community considered Andromeda to be a distant nebula, perhaps outside our universe altogether. Then, in 1924, Hubble made a monumental breakthrough by proving that Andromeda and other similar nebulae were, in fact, galaxies, vast collections of stars similar to our own Milky Way. This discovery reshaped our understanding of the universe. Only a century ago, we believed Earth was the center of everything, and that the sun was merely a hole in the sky shining down divine light on us. When Galileo suggested that Earth revolved around the sun, he was forced into house arrest for his beliefs. It wasn't until much later that the Church accepted the truth. Similarly, the idea of galaxies beyond the Milky Way was once unimaginable. Andromeda, once thought to be a distant cloud, was revealed to be a vast spiral galaxy, twice the size of our own Milky Way, with a diameter of around 220,000 light-years, compared to our galaxy's 100,000 to 120,000 light-years. Not only is Andromeda larger, but it also contains an estimated 1 trillion stars, far surpassing our Milky Way's 100 to 400 billion stars. This dense star population makes Andromeda a prominent feature in the night sky, and the discovery of other galaxies was a monumental achievement in astronomy. Today, we know that there are approximately 50 billion galaxies in the observable universe, with some estimates reaching as high as 200 billion to 2 trillion galaxies, most of which are located in a supercluster known as the Shapley supercluster. Thanks to the James Webb Space Telescope, Andromeda is now seen in a new light. Webb's advanced infrared technology is allowing astronomers to see deeper into Andromeda than ever before, revealing intricate details hidden by previous technologies. Infrared telescopes like Webb have revolutionized our understanding of the cosmos. They provide insights into cool objects that don't emit visible light, making them especially valuable for studying young stars and the regions where stars are forming. Webb's infrared vision also allows it to penetrate thick clouds of dust and gas, uncovering the complex structures of galaxies, including the active galactic cores and massive black holes that lie within. The phenomenon of galactic cannibalism, where a larger galaxy devours a smaller one, might sound like the plot of a science fiction movie, but it is a real galactic process. When galaxies come close enough to one another, their gravitational forces can cause one to tear apart, with a smaller galaxy's stars, gas, and dust being absorbed by the larger galaxy. This often leads to explosive star formation and disturbances in the galactic cores. The Andromeda Galaxy is a prime example of this process, as it is on a collision course with our Milky Way, and its immense gravity is likely to disrupt the structure of both galaxies. These cosmic events are fascinating, but they also raise questions about the future of our own galaxy and the potential consequences of such cosmic collisions. Unlike ordinary matter, dark matter does not transmit, absorb, or reflect light, making it invisible to traditional telescopes. Its existence is inferred through its gravitational influence on visible matter, such as stars and gas clouds during galactic mergers. Dark matter halos surround galaxies and interact with visible matter, possibly driving the formation of new cosmic structures. Studying galaxy mergers is essential for understanding the past and future evolution of galaxies, as well as testing our theories of cosmology and gravity. Observing these mergers offers valuable insights into how galaxies form and evolve over astronomical time, shedding light on the processes that have shaped the universe since its early stages. In addition to their scientific importance, cosmic mergers captivate the imagination with their stunning displays. One of the most spectacular is the impending collision between the Milky Way and the Andromeda Galaxy, known as Milkomeda, which will unfold over billions of years. This grand cosmic dance will feature swirling arms of galaxies, stars being thrown into new orbits, and new star clusters forming amid the chaos. When the Milky Way and Andromeda merge, they will create a single, larger elliptical galaxy, marking the end of their distinct identities. The Milky Way's spiral arms and central bar will combine with Andromeda's own spiral structure, resulting in a new galaxy with a unique appearance. Over time, the distinct features of both galaxies will blend together, creating a new cosmic entity that astronomers will study for centuries. This merger will not only alter the galaxy's appearances but also their stellar populations. Gravitational interactions between stars from both galaxies will fling some stars outward into intergalactic space, while others will be captured in new orbits around the newly formed galaxy center. This dramatic process will lead to a reshuffling of stellar ages and compositions, creating a diverse stellar population within the newly formed galaxy. For astronomers, the Milky Way-Andromeda merger offers a unique opportunity to observe a cosmic crash firsthand. By studying the newly merged galaxy in detail, scientists can learn more about star formation, black hole development, and galaxy evolution during such cataclysmic events. The data gathered during Milkomeda will provide critical insights into testing existing theories and refining our understanding of how galaxies develop and change over time. One fascinating aspect of cosmic mergers is their role in triggering bursts of star formation. As gas clouds collide and compress during a merger, they can collapse under their own gravity to form new stars. These regions of intense star formation, known as starburst galaxies, are characterized by rapid star creation, producing thousands to millions of stars in a short time. In the case of Milkomeda, the collision between the Milky Way and Andromeda is likely to cause a significant increase in star formation activity. The merger will compress gas clouds in both galaxies, triggering waves of new stars across the combined system. These young, hot stars will illuminate the merged galaxy, creating a vibrant tapestry of light against the darkness of intergalactic space. The merger will also affect the fate of planetary systems within the two galaxies. As stars and planetary systems are disturbed and restructured during the collision, some planets may be ejected from their original orbits, while others may be captured into new orbits around the newly formed galaxy. This massive transformation could have profound implications for the habitability of any remaining planets, as their orbits and environments may be drastically altered by the merger's aftermath. The study of cosmic mergers also enhances our understanding of the larger structure of the universe. Galaxies rarely exist in isolation. They are often found in clusters or groups bound together by gravity. The Milky Way and Andromeda, for example, are part of the Local Group, a small collection of galaxies that also includes the Triangulum Galaxy and several smaller satellite galaxies. As the Milky Way and Andromeda merge, their combined gravitational influence will reshape the dynamics of the Local Group, altering the orbits and interactions of the member galaxies. This interaction could lead to future mergers among other galaxies in the Local Group, further altering its composition and structure over vast periods. In conclusion, the merger between the Milky Way and Andromeda represents a pivotal moment in the vast history of our universe. It is a testament to the dynamic and ever-changing nature of galaxies, as well as the fundamental processes that govern their evolution. By focusing on Milkomeda, astronomers can gain invaluable insights into the processes of galaxy formation, black hole growth, and the distribution of dark matter, advancing our understanding of the universe on both a local and cosmic scale.